Hello everyone, welcome to my channel HyperMesh Basic to Advanced. So to have a bit of a background about my channel, so in this channel I make videos related to FEA and HyperMesh. So if you are new to this channel, kindly consider subscribing to this channel as I make videos related to FEA and HyperMesh. And if you are already a viewer and not subscribed, kindly consider subscribing as it motivates me to make more videos, correct? So moving on to today's topic. So in today's video, we'll be discussing HyperView, right? How to use HyperView and how to analyze results in HyperView, correct? So when you open HyperView, you have a window like this, correct? You will have the component here in the window and you have different options to explore to analyze the component, right? So moving on to the first panel, which is available to us, we have the contour panel, correct? If you can see here, this panel, contour panel, it's this one, correct? If you can see my mouse. So what is in this panel is, if you can see here, we have the result type, correct? So under result type here I have displacement and element stresses. So result type is basically all the results you request, correct? It can be displacement, stress, strain, acceleration, temperature, okay? So it depends on the type of results you request, correct? So if you can see, I have selected result type as displacement, okay, and if I click on apply, okay, it's already applied. You can see the contour plot for the result, for displacement result, correct? So if you can see, so the red region, the values are somewhere between 2.846 to 3.2, correct? If you can see in the model here, so I'll just turn the model a bit. If you can see in this region, correct, it looks red. So there the values are in between these values, correct? Okay. So suppose I want to see the stress values, correct? So I'll change the result type to element stresses here. Then here the selection on which parts, components or elements, if you can see here, I want to analyze that. So I'll just click on components, I'll click on display, it will select the whole component here, correct? And I will click on apply. So if you can see, the contour plot has changed to element stresses here, correct? And the values are as follows. And on the screen, you can see the uh, change in the color of the elements, right? According to the contour plot for the element stresses, correct? So then below that, you have the option to select different kinds of stresses you want to view, right? Like one might say sine, one might say tresca, XLT, major, minor, correct? And you can even view the stresses along different directions, correct? So likewise I click here and you can see it gives you along XX the max, correct? Then you can go to YY. So if you see, the values are changing here, correct? So this is basically at your disposal here, right? So we'll just go with one mysis here for now, correct? So this is the result which you want to see in the direction or what type of result you want to see for that result type, correct? And below that we have layers. So basically what is layers is basically used for composite structures, correct? If you have seen my composite video, my hyperlaminate video, if you can just go and check if you have not checked, so in that I explain how composites are made in hypermesh, correct? So in that different layers are there, correct? So here you can analyze different layers of the composite, right? So this is for that, right? Okay, then there's averaging method, right? So here averaging method we have taken as none, right? We can change it to simple. This will change the plot a little bit. If you notice, simple here the max value is around 1.977 10 to the power 3, then it goes to 2.14 into 10 to the power 3, correct? So maximum. So in this way we can just change the averaging method and check, correct? Then value filter. So value filter is like if you want to see some regions where the value is greater than something, right? So suppose here element stresses are the range max is 2.14 into 10 to the power 3, correct? So suppose we want to see something less than 1.5 into 10 to the power 3, correct? So we'll just make it 1500, correct, and we'll click on apply. Okay, so if you see all the what do you call stresses less than 1500 are plotted here on the component, correct, and in the legend also you can notice it's less than 1500. So if you just remove it, correct, notice this change, correct. So you can just see the values according to your need, and you can just filter it out from here, correct. Okay, so this is the contour panel. Okay, so next we'll move on to the ISO panel. This is the contour panel, and next is the ISO panel. If you can see this one, correct, you click here. Okay, so the ISO panel, basically what is the use of the ISO panel? So ISO panel basically helps us to like overlap some results, correct. So suppose the result type selected here is element stresses here, correct. So if you can see the element stresses are plotted here. Okay, and averaging method is set to none. So what we can do here is, suppose we want to see regions where stress is like more than 1500. Okay, or 1400 we'll take for this example, correct. So we'll set the filter at 1400 and we'll click on apply. So you can see the regions where the stress is more than 1400 is shown here, correct. Okay, this is 107, so we'll make it 1400 again and we'll press enter, correct. So the regions where the stress is more than 1400 is shown here, correct. Okay, so how do we like overlap it in the geometry, the component? We can just go here, features, transparent, correct. You can see the regions where those stresses are more on the geometry, correct. You can see it's about center line, correct, and it's diverging here a little bit, it's spreading out, you can see, and this corner part, these all elements have stresses more than 1400, correct. So where does this help? So this can be useful if you want to analyze the regions where the stresses are more than certain values. So you can just put the result type for stress, result type as stress, and you can select the filter value here, and you can just overlap the geometry and you can check which all regions are exceeding those stress values, right. Same you can do for the displacement part, correct. Okay, so we'll just clear the ISO. So if you just click the clear ISO button, so it will clear the plot on the screen, correct, as you can see, correct. Okay, so moving on to the next panel, we have the vector panel, correct. If you can see here, vector. Okay, so before that I forgot to tell you one thing. I'll just go to the contour panel again and I'll tell you one thing just as a tip. So if you can see something, you have displacement written here, right. So next to displacement you have a V written in the bracket, if you can see here. Okay, so what is this V? So this V basically stands for vector, correct. So if you know displacement is a vector, correct. So, and if you go to element stresses, you can see if I can just expand it, it will show up. Okay, so if you just drop down, so element stresses, you will see a T written in bracket. So what is that T? That T means tensor, correct. So the displacement vector and element stress tensor, correct. So the vector panel, we have all the vectors, we can analyze the vectors, correct. So in result type, if you see, we'll only have displacement here because displacement is the only vector in the result type which we have requested, correct. So we'll go to components again, we'll click on displayed and we'll just click on apply. So if you can see on my screen, the vector are displayed, correct. So the displacement vector plot is for x plus y plus z, correct. If you can see there we can select it, correct. So if you just uncheck this, and we'll check for x plus y only, then it will display for x plus y. Correct. If you can see here, you can see how the vectors are lining up, where the maximum displacement is, where it's coming at the edges, it's low, at the center parts it's getting maximum. Correct. You can see this curve, the increasing magnitude of the vectors. Correct. And we can just click on x, y and z. Correct. And you can see this. Correct. So basically this is how you see the vectors. Correct. These are the resultant vectors, and these are the vectors of the component, the normals of the elements which you have meshed. Correct. So we'll go for z plus x. If you see, so you can see how it's increasing. Correct. If I can just show you like this. Okay, so you can see how it's changing. Correct. Fine. So basically this is the vector panel, okay, where you can analyze the vectors, how they are changing throughout the component. Okay, so we'll clear vector. Okay, so next part, what is the next part? So next we'll move to tensor. So this was the vector panel, next is the tensor panel. Correct. So we'll go to a tensor panel and we'll just go again, and as you can see here in the result type, you only have element stresses because that is the only tensor in the results we have requested. Correct. So elements, we'll just change this to components. We'll click on displayed, we'll click on apply. Correct. So if you can see, the tensors are displayed. Correct. So here we are displaying all the things, the major, minor and mid. Correct. So we can just remove the mid and minor and we can click on apply, so you can see the major. Correct. So if you just zoom in here, you can see how it's forming. Correct. And you can just go down here and see the values. Okay. Yes. So you can see how it's changing there. Correct. Fine. So again, you can check all the things. You can change the tensor format also here. Correct. Okay. And display value size scaling, you can change by magnitude normalizer. Okay. Draw mode, regular movement, crossfoot, whatever you want. Okay. So basically this is the panel which is used to analyze the tensors. Correct. So when you have seen that, you can again click on create tensor to clear it. Correct. So that will erase the plot. Correct. Okay. So basically we have till now we have seen contour, ISO, vector and tensor. Correct. Okay. Now the next thing what we will see is basically the deformed part. Correct. The next panel, deformed. If you can see here, just I'll click this. So deformed shape, if you can see here. Correct. So what is this used for? So suppose you want to see how the structure is deforming. Vector you analyzed on what directions it's deforming, but you want to visualize as a whole to see it moving. Correct. So you can just check it out here. If you can see this, you have a media player. Okay, you just click this, you can see it deforming. Correct. But suppose this scale is, if you can see here, the value I have scaled it by 5. So if you just wait, I'll just make it 1. Correct. So this is the actual value. So if you can see here, you can't notice the deformation very much. Correct. Only one side you can notice the deformation, but other sides you can't notice the deformation properly. Correct. So what we can do here is deformed shape is, we can just go to the, I'll just pause this. Correct. I'll just bring this back. Correct. So this value we can change to some factor. Correct. So I'll just put 4 for now. This is a scaling factor. Correct. Scale factor we have mentioned, and we have put the value of 4. Apply. Correct. So now if we see, so there's a reasonable deformation. You can see it visually. You can easily see the deformation. Correct. And if you want to scale it a bit more, you can scale it again. Suppose we keep it as 8. Correct. And we'll click on apply and just click on OK. You can see how much it's deforming. You can clearly see it, correct? It's very much okay. So okay, you are seeing this deforming, correct? So what if you want to see how it's deforming from its previous state, correct? So what we'll do is undeformed shape is here, correct? So from here we'll go to wireframe, correct? And we'll select component. We'll let it be the component for now, and we can just play it. So if you can see here, you can notice how the top flange is coming down from its initial position. You can notice this clearly, correct? And similarly for the mid surface, correct? So I'll just pause it. Okay, we can change this to mesh also. So I think this will be properly visible now. So you can see how it's coming out from its previous position. Same for the bottom flange, correct? So basically this is the deformed panel. Okay, so next we have the query panel, correct? So before going there, I'll just change this to none. I'll change the scale factor to 1. Okay, fine. So next we have the query panel. So what is the query panel? Okay, so if you can see here on the screen, I'll just show you. We have the legends here, right? So this legends, they give the range, correct? They don't give the exact value. So the red region, so if you see the red region, these values, it's basically saying it's in this range from 1.9 to 2.14, correct? So what if you want to see the exact value at some place? So basically you can go here and click on the element which you want to see the exact. So you click here, correct? So this is the element ID here. What element ID is there? It's configuration, element connectivity, component name, and you have the element stresses here. So if you can see the element stress here is 2.09 10 to the power 3. If you click this one, it's 2.116 10 to the power 3. 2.052 10 to the power 3, correct? And if we go in the orange region, suppose we click this one, 1.77 into 10 to the power 3. So basically this we can check what are the exact values on those elements if we want to see them, correct? So we can just clear the table after we have seen, and we'll just clear the table, correct? And here in this list you can select what all you want to be displayed here. Suppose I want the material ID to be displayed. Okay, so I'll click on here. So you see material ID, but it's not applicable. Okay, we'll select something else. So suppose we select the part, correct? And we'll click on this, correct? Okay, part is also not applicable. But this is basically for selecting the field which you want to display here. Okay, so like element ID, element configuration, connectivity, everything is selected, so it's getting displayed here, correct? Okay, so we have cleared the table now. So basically that is how you can see the exact values in that, correct? So basically these are the panels which are mostly used, correct? And this is basically for playing the animation. So here you can just play the animation, correct? And this is for the speed of the animation. So if you increase this, you can see how fast it's moving, correct? Okay, so basically this was for seeing the results. And now coming to this side, if you want to see, so if you can see this is basically for masking. Okay, you can mask elements here if you want to mask them, correct? This is the mask and unmask. Mask selected, correct? Then you can reject. Okay, so this panel is basically related to masking and unmasking. And this white browser area, it's similar to hypermesh. You can just hide components, correct? Here you can see the load cases, correct? So basically this is the very basic introduction for HyperView, or it's more than basic if you can say, because I haven't seen people like exploring all these panels, correct? I've mostly seen people using contour panel at the most. I've never seen people using ISO, vector or tensor to analyze, not even query most of the time. So basically this will be more than enough for you to just analyze structures, correct? So this is a very more than basic uh, introduction to Hyperview, correct? Okay, so I hope you got to learn something new from this video. This video was helpful. So if you like the video, please consider subscribing and liking the video and sharing it so that its reach grows, correct? And I'll try to make more videos more frequently, correct? I've been sick for a while now. I was not able to make videos, so this video came after a long time. This was in pipeline, but it got delayed. Okay, so thank you very much for watching the video. Hope you got to learn something new, and just stay tuned for more videos related to FEA and Hypermesh. Thank you.